My friends, here let us study the first three-dimensional geometrical figure of our chapter Mensuration. It is a solid figure or is called three-dimensional figure. Okay, now if you see towards this figure, then you can see that here what type of figure it is. So first of all, let us introduce this figure called a cube. Our first three-dimensional geometrical figure is a cube. Now if you observe toward this figure, then it is hollow inside. It means nothing is there. It is empty, hollow inside, and it is just like it is just like our room. Our room has walls. Okay, like this figure also, a cube also, it has wall type of structure. Okay, it means it is a flat surfaces are there. Wall is a flat, like this it has walls, and inside it is hollow. This type of figure we have, but its specialty is what is mean by cube. A solid figure cube. A cube has all the length of all the sides is of equal length. This side is equal to this side, is equal to this side, and all the sides are of equal length. Such type of figure we call it as a cube. Now first of all, we want to study about the parts of this cube. What are parts of the cube? Now I will say that if you concentrate on these corners, you see, can you see this corner? This corner, this corner, this, and so on. So this type of corners I will name it at first in order to study it in detail. Now here this corner I will name it as A, B, corner B, C, D, and so on. Likewise, here I will name it as E, F, G, H. Okay. Now I want to know or count in all total how many corners are there. So first of all, let us count the corners. Can you say how many corners are there? Here if you observe toward the figure, then if you count the corners, then you can see that there are 1, 2, 3, 4, 5, 6, 7, 8 corners, and these corners, they are called vertices. What they are called? They are called vertices, and vertices are denoted by letter V. Vertices are denoted by letter V. Now here I am going to count vertices V. Can you say how many vertices are there? Here if you count number 1, 2, 3, 4. At the top 4 vertices are there, 4 corners are there, and at the bottom 4 corners are there. Thus in all there are 8 corners or 8 vertices. So I will write 8. This is in case of our first article, that is corners or say vertices. Now let us move on to what is mean by edges. Now we want to know about the edges and what is mean by edge or edges. Now what is mean by edge? The edges means if you see toward the figure, then the segment B to C. Okay, where the two surfaces or walls of the room they are attached. Here you see they are in contact. B to C or C to B segment. A segment B to C or C to B is called as edge, and edges are denoted by letter E. Can you see in the figure how many edges are there? So here we will count the edges. How you will count the edges? Here, if you see at the top, then how many edges are there? Here B to C is one edge, A to B another, here D to C this, and D to A to D or D to A. Like this, how many total in all? How many total edges are there? At the top 4 and at the bottom E to F 1, F to G 2, like this, G to H 3 and 4, like this. At the bottom 4, what is left now? Here if you see the vertical edges, then they are 4. So like this, again vertical 4 edges are there. So in all there are 12 edges. How many edges are there? In all we have 12 edges. Got? Now what we want to see now? Now we want to see about the faces. What is mean by face? A face is nothing but a flat surface. Face. To which part we call it as a face? The faces are denoted by letter F, and you know, I told you that a cube is just like our room. How many walls are there? To construct one room, how many walls are required? You know, here if you see toward the figure, then BCGF is a right hand side wall, this one. Okay, so here we are going to count it as walls, and you know, the walls I am going to call it as a faces only, flat surfaces. Okay, that's why I am going to call it as a faces. And how to count? To right hand side one wall is there, so one face is there. Okay, left hand side one wall is there, so one face is there. To front side one wall is there, our entrance A, B, F, E, one more. So, and back side one more. Therefore 1, 2, 3, 4 you got. Now there is a wall, again flat surface at the top, so that is 1, and at the bottom also there is a flat surface 1. Count in all 1, 2, 3, 4, 5, 6. Thus we have in all 6 faces. Therefore here we have in all 6 faces. Okay, now here such type of figures, if you are going to see a like this cube type of figures that we have, and the figures that they have the flat surfaces. What? Flat faces. If you observe towards the face which we are going to call it as a wall, PCGF, right hand side wall, front, left hand side, front side, back side, top and bottom. So these faces, if you see, then they are flat, they are not curved. Flat means they are not curved. And the edges, if you see, these edges they are straight. So the solid figures that they have the flat surface and straight edge, we used to call them as polyhedra type of figures. What? Polyhedra. Polyhedra. And you know, A polyhedra type of figures, they hold a particular relation. What type of relation? What is mean by polyhedra type of figures? A polyhedra type of figures, they have flat what surface and what I told, straight edge. Second, and they have straight edge. This type of figures, solid figures, they are called what? Polyhedra. Straight what? Edges. This type of figures we call it as polyhedra. Now what type of relation they hold? The polyhedra type of figures, they hold a like this relation and it's given by Euler's formula. The relation is given by Euler's formula. What is that relation? The relation is, it is in between the vertices, edges and faces. Okay. What Euler's formula tells us? The Euler's formula, it tells us the relation between vertices, edges and faces. And what is that relation? F plus V is always equal to E plus 2. F plus V is always equal to E plus 2. What is the meaning of this? How many faces we got? Let us check how many faces we got. We have 6 faces. What is mean by V? How many vertices we have? If you observe towards vertices, then they are 8. And how many edges we got? Here we got edges equal to 12. So we have 12 edges plus 2. Check out 6 plus 8, 14. That is equal to 12 plus 2, 14. Thus Euler's formula verified. Now let us take one more figure to check out whether the Euler's formula it also holds correct for any other type of polyhedra type of figure or not. For that purpose, let us take one figure. Now observe toward this figure. If you observe toward this figure, then first of all, let's carry out the naming again. To the corner, say A, let this point is B, C, D, E, F and G, H, I, J, K, L and so on. So now here can you say how many corners are there? And what we call it as the corners? We call a corner as vertices. How many vertices are there? At the top there are total 6 vertices are there, and at the bottom there are 6 corners, means 6 vertices. So in all there are 12 vertices. How many edges are there? If you count the edges, then at the top there are here A to B, B to C, C to D, D to E, E to F, F to A. How many? Total 6 edges are there. Likewise at the bottom 6 edges are there. And if you see vertical edges, B to H, A to G, C to H, D to J and so on, like this, there are 6 edges. So in all we have 18. Now let us count how many faces are there. Can you count how many faces are there? You know, faces means flat surfaces. Walls. You know, vertical 6 walls are there, that we call it as faces. At the top there is one more wall, that is hexagonal, and at the bottom there is one more wall. In all, total how many faces are there? 8. 8 faces. Let us check out the Euler's formula. It tells us that F plus V is always equal to E plus 2. F plus V is always equal to E plus 2. Let us count. How many faces are there? We have in all 8 faces. Plus, how many vertices are there? In all, we have 12 vertices. Let us count how many edges are there. There are 18 edges and plus 2. Thus, here we get 12 plus 8 is equal to 20, and 18 plus 2 is equal to 20. Got? Thus, a Euler's formula, it holds good for polyhedra type of figure having flat surfaces and straight edges. Okay, so that's here we have studied about the parts, edges, vertices and faces. Now in the next article we will study how to calculate total surface area and volume of a cube. Okay.